Hello, a specialist to Prof. Dr. Zainal. Today I would like to talk about my research medical specialty based on special study module. My name is Joevier Jamesron. Let's move on to our content. This is my contents. As you can see, it have four main content here, include the conclusions. So let's move on to who is my favorite doctor. My favorite doctor is Dr. Ang Hak Lee. He is the pediatrician's cardiologist and a consultant and now currently working in the Sunway Medical Center at Selangor. Why? He have 20 years of experience. How good it is. And he is awarded by an excellent service certificate from the University of Malaya in 2015. He did a Master of Paediatrics and also a Fellow of Academy Malaysia of Asian Federations of Cardiologists and the FNHAM, the National Heart Association of Malaysia. His contribution, why he's very popular, and we can see on the internet. He treats transthoracic echocardiographies, diagnostic cardiac catheterizations, percutaneous cardiac intervention, and vaccinations. So he treats the heart, both the vessels, the coronary artery surgery, congestive heart failure treatment, and coronary angiogram. We can see more here at my list. Next, my findings. My finding is about the cardiovascular systems that I like. That will be the heart. The cardiovascular system here is known as a circulatory system, consists of blood vessels, blood, and heart. It is the scientific study of normal heart, and this is associated. It is known as cardiologist. So for blood to reach all the throughout the body, it needs to pump continuously by the blood to the blood body vessels. So it have four main chambers that are right and left atriums, right and left ventricle. This is where the large volume of blood will be accumulated. Where's the locations? So the location will be at the mediastinum. As we can see, mediastinum, superior surface of the diagram, superior surface, it is upper from the diaphragms, and it is left of the midlines. Okay, so it have four main border that is superior, upper, and inferior, downward, left, and right. So the most important thing is it have also pericardium. It is not like a tissue, it is a fibrous sac that function as to protect and encourage the heart, prevent the overfilling of the blood. And we know the pericardium is the visceral, the inner, and the parietal outer. And between these two, it have a fiber. It is a fluid that will make the heart will contract in the free frictions. So there will be no injury happens when the contraction happen. So this is basically what I have been taught, that is the four main valve of also that have been highlighted here in the box: tricuspid valve, mitral valve, aortic septal valve, and pulmonary valve here. Yes, and it is also separated by these interventricular septums to separate the oxygenated blood and oxygenated blood. This is the frontal section of the heart. So the physiology of the heart is it functions to contract and to pump blood throughout all the body cell and all body tissue in our upper limb and the lower limbs. So beautiful, right? How the heart works. So the blood enter from the right atrium to the superior vena cava here, superior vena cava and inferior vena cava, and it goes to the right atrium, and then it will goes to the right ventricle and goes to the pulmonary trunk. What happened here? So to enter to another region of regions, it need a valves. Yes, a valve. So this valve functions so the blood will flow in unidirectional, and it also same goes as the left of our heart. So it will goes from the right and left pulmonary veins and goes to the left atrium, and it goes to the left of our ventricle, and it will goes to the aorta and all throughout our body. So the innervation is the vagus nerve and sympathetic cardiac nerve here. So the vagus nerve is to decrease heart rate, and sympathetic cardiac nerve is to increase the heart rate force of contractions. So this is the innervations it follows from sinoatrial node and goes to the AV node, atrioventricular node, bundle of His, and go to Purkinje fibers throughout the whole ventricle of the heart. Next, the physiology is the histology we'll be talking about is the tissue of the cardiac muscle. So basically, it have this nucleus and it is branching, and one centrally located nucleus, not peripherally, and it is not junctions, not tightly junctions. It have gap junctions, and between the gap junction, it have what the desmosums, which hold the fibers of the muscle together, which allow the muscle to contract in a single coordinate unit as syncytium. Why? So this is the interconnected disc as we're talking the gap junction here. So when the muscle action potential will conduct from one muscle fiber to its neighbor, so this desmosum will spread the stimuli to whole in the syncytium, that is coordinate unit. Next, for the biochemistry is I will be talking just a little bit. This is phase 0, phase 1, phase 2, and phase 3, and phase 4. So phase 4 is the polarization due to rapid influx of Na+. So Na+ here will be functions to make the contraction of the heart happen. Then phase 1 is partial repolarizations occur due to closure of Na+ channel. And the plateau phase, this refractory period. Why they are supposed to be a refractory period is to allow the heart to relax, so there will be no tetanus. So if there will be a tetanus, there will be cardiac arrest. The heart will be pumping without relaxing, so the blood cannot enter because of the continuous contractions. So next, the phase 3 will be repolarization of U2 K plus efflux and closure of Ca2+ channels. The resting membrane potential achieved at the phase 4. So this is how the beautiful of this. You can see here, it also work as like a skeletal muscles. So this thin muscle, this thin layer here will contract more, goes to each other and then like crashing into each other, but not. So this is where the contraction happens. This is where the Na+ will give role in here. So the paediatric disease of myocarditis is, as you can see, it is the inflammation of the heart, the muscle. The myocardium is the muscle of the heart, and itis, that means inflammations. So how maybe some of the when the in the fetus and the mother, maybe the mother will bring the germs from his blood into the fetus. How? The germ will enter the body, then travel through the bloodstream into the heart. It will suddenly grow and could cause a damage to the cells. Normally, the immune cells will take action to destroy these germs, but for the fetus and maybe for the children, unfortunately, this response will be too over-aggressive, because not only the germ is destroyed, but maybe the muscle cells will be damaged. Myocarditis could happen. So it will interfere with the heart function, and the heart muscle can be permanently damaged. It will also weaken the myocardial contractility by the inflammations disrupts the normal function of heart muscle cells, reducing the ability to contract forcefully, and consequently it will lowering the cardiac output. So this basically here is the factor, that is virus infection and sign of the symptoms when you get pale, cool hands and feet, fatigue, and more in here. So how we should diagnose this? To be sure, we have no true diagnosis, but we can diagnose a little bit by using an X-ray, echo, electrocardiogram, and echocardiogram. As we can see in here, we can read here. Okay, it is no specific test for myocarditis, but we can diagnose it with these steps. Okay, so basically the review, this is the extra review of the 10-year-old children's. Okay, so maybe some of the in aspect of biochemistry, when the heart muscle inflamed, it will release the inflammatory markers, that is C-reactive proteins, CRP, and interleukin 6 IL-6. Okay, this is the review of the heart muscles when there is myocarditis. So in conclusion, there are many more special functions in the structure of heart that can be explored more. It is crucial to treat children that have heart disease because they are the new generation that will continue to grow and the one that will lead the country. So I think that's all from me. Thank you and have a nice day.